Hello class, and welcome to section 3.4, which is about arithmetic sequences. By the end of today's lesson, you will be able to identify and describe arithmetic sequences. First off, a sequence is a list of numbers in a specific order. So I've got a few different examples here. 1, 2, 3, 4, 5, very obvious, you're just going up by 1. Some patterns are a little bit more difficult to find. So 1 and then 1. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. So it's not a specific pattern where we're consistently adding, but it is a pattern. So a sequence just has some sort of pattern in a specific list. The type of sequence that we're concerned about for this particular lesson is called arithmetic sequences. This is where the sequence is going, each successive term has a constant difference. So we're not worried about these ones where we're changing what we're adding. We're worried about these ones where they stay in order, going up or down by a specific amount every time. That specific amount we're going up and down by is called the common difference. So if we look at this one, 3, 5, 7, 9, 11, our common difference is 2. We're increasing by 2 every time. The one on the right here, we've got negative 21, negative 25, negative 29, negative 33. We're going down by 4 every time, so our difference is negative 4. So we're looking for these patterns where we can add and subtract to get to the next number. Each number inside of a sequence is called a term. So if we're looking at this first one, 3 would be the first term, 5 would be the second term, etc., etc. Same thing would happen for this one. Negative 21 is the first term. Negative 25 is the second term. That tells you what place it is in the order. There are 2 different types of formulas for arithmetic sequences. The recursive formula says any number, so an, can be found by taking an minus 1, so the number before it, and adding the common difference. That's what D stands for. So any number can be found by taking the term before it and adding the common difference. This works really well for smaller values. So if you're trying to find the second or third term, it's not going to be very difficult to add it up over and over. It also means that you need to know the first term. So you need to know the first term, and it works really well if you know the previous term. So for example, they give you the 50th term and they ask you for the 51st term. You're going to be able to use this because we could plug in 50 and add the difference to find that next term. The explicit formula, which is much more practical, allows you to find any number. Same thing here, but it doesn't require you to know the number before it. So any number is equal to the first number plus the common difference, and then in parentheses, n minus 1, so that's our term number minus 1. So this one works really well when you're finding bigger values, so bigger terms. For example, if it's asking you for the 100th term in a sequence, you're not going to want to add over and over 100 times. So this formula allows you to do the shortcut. Again, it is important that we know, so we need to know the first term. So again, recursive we use more so when we know the previous term, and the explicit we know when we use the first term. So we're going to start by looking at the recursive formula. So it asks us to write the recursive formula to represent the total height of the nth step of a staircase if the height of each step is 18 centimeters. So what we need to know here, the first thing we're going to note is that our first step is at 18. So our first step is 18 centimeters high because each step is 18 centimeters high. So our first number is going to be 18. Then to write out my formula, I would say an, so any number, is equal to n minus 1, the number before it, And then our common difference in this case, what we're going up by every time, we're adding 18. The reason we're adding 18 is each step is 18 centimeters, so every time you go up a step, you go up by 18. Now it's asking us to find the height of the fourth step. So we know the height of our first step, so A1 is 18. Now to apply this formula, to find the second step, we would say A2 is equal to A1 plus 18, because the number before 1 is 2. We know what A1 is, so we can put 18 in. So A2, the second number in our sequence, is 36. Then we would continue. We're looking for the fourth, so now we're going to go to the third. So we would take A2 plus 18. Again, we know what A2 is, so we've got 36 plus 18, which gives us 54. And now finally we want that fourth step. So A4, which is equal to A3 plus 18, we know that A3 is 54. So we've got 72 centimeters is the height after that fourth step. So we had to go through step by step and find each of the next terms. Go ahead and try this one on your own. So our recursive formula, the first term is 5. We've got an equals an minus 1 plus 5. And then since we're finding the third term, we did the first, add 5 to get the second, add 5 again to get the third, which is 15 ounces. When we use the explicit formula, this is going to help us be able to find any number, especially the bigger ones, the bigger terms, so that we don't have to count individually. So the cost of renting a bicycle is given in the table. What is the formula for the table? So we're looking here, days 1, 2, 3, 4, cost 26, 38, 50, 62. What this is telling us, this days, is actually our term numbers. So the first term is 26, the second term is 38, the third term is 50, and that last term is 62. So we're looking here at the actual list of numbers is our cost. So our cost is our sequence. The days is just telling us the order of the numbers. So in order to do an explicit formula, we're going to need our A1 value, or our first term, which is 26. The other thing that we need to know is the common difference. How much are we going up by? To get from 26 to 38, I had to add 12. To get from 38 to 50, I had to add 12. To get from 50 to 62, I had to add 12. So my common difference is 12. Then, to write my formula, I would have AN is equal to my starting term, 26, plus my common difference, which is 12, times n minus 1. So that's our term minus 1. In order to make this a little simpler, we're going to simplify the equation using the distributive property. So we've got AN is equal to 26 plus 12n minus 12. Since 26 and minus 12 are both numbers, we can put those together, and that is going to give us that AN is equal to 12n. 26 minus 12 is going to give us plus 14. So our formula for this equation is AN, any term, is equal to 12n plus 14. Then it asks us to solve. What is the cost of a rental for 15 days? So we can use this, and we're going to say A15, because we want the 15th term, is equal to 12 times 15 plus 14. And when I do that, I'm going to get an answer of A15 is equal to $194. That's my cost if I do the rental for 15 days. Go ahead and try this one on your own. Our formula starts with a Common difference of 3 and a first term of 7. When I simplify, I end up with 3n plus 4. When I'm finding the cost of an 18 dessert platter, I plug it into my formula and get an answer of $58. The last thing we want to be able to do is to go in between the two formulas. So this one gives me the recursive formula, the a equals an minus 1 minus 3 with my first term of 2.4. So we're trying to go from the recursive to the explicit. So what we need is that first term and our common difference, which is negative 3. So now I can plug it into the explicit formula and say an is equal to my starting number, 2.4, plus my common difference, which is negative 3, times n minus 1. I'm going to distribute to get rid of that, and I've got an is equal to 2.4 minus 3n plus 3. I can put my 2.4 and my 3 together, which gives me an is equal to negative 3n plus 5.4. So I took my information from my recursive formula and was able to turn it into the explicit formula. Go ahead and try this one on your own. When you do this, you've got a1 is 7, the common difference is 4. So you're going to go ahead and plug it in, distribute, and get a final answer of 4n plus 3. Last thing is we want to be able to go from our explicit formula back to our recursive formula. So we need to be able to pick out our common difference. Our common difference is always going to be our value with our variable. So in this case, our common difference is 3. And then we need to find our starting value. So we're going to say a1 is equal to 8 times 3 plus 1, because I can use this formula to find any term. So in this case, a1 is 8 plus 3 times 1. 3 times 1 is 3 plus 8 is 11. So then to write my explicit formula, or excuse me, my recursive formula, I would say a1 is equal to 11, and then an is equal to an minus 1 plus 3, because that's my common difference. So that would be my my recursive formula that I was able to get from the explicit formula. Go ahead and try this one on your own. Common difference is negative 5. We're going to solve to get our first term, which is 3. So our explicit formula is a1 is 3, an is equal to an minus 1 minus 5. If you have questions about this or anything else from the lesson, please let me know when you get to class.